Okay, so here's a very basic scatter diagram question. So I say Neil owns an ice cream van. This scatter diagram shows information on temperature and number of ice creams he sold each afternoon from the 1st of August to the 7th of August. So why are there 7 crosses? Well, each cross represents one day. Okay. On the 8th of August, it was 21 degrees C in the afternoon and he sold 40 ice creams. Plot this information. So temperature 21, ice creams 40, it's about there. Try and be really, really accurate. Describe this correlation. It's strong positive. So that means as temperature increases, so does the number of ice creams sold. Now this time we don't actually have the actual data, or we don't have it written down, so we wouldn't use a calculator to find the regression line. We just do the best that we can. So there is my regression line, okay? I'll do the best that I can to make it go through the data. I wouldn't use a calculator for that because I don't have the numbers, okay? Estimate the number of ice creams Neil sold that afternoon when the temperature was 28. So again, I expect to see lines drawn. So we go up to the line and across. I think that's about 63 ice creams sold. On 28th of September, it was 10 degrees. Does it make sense to use your line of best fit to estimate how many ice creams we sold? And the answer is no, because that would be an example of extrapolation. I'm looking at data that's outside the range of what you've already got. Okay, so no, it's extrapolation. Okay, so we don't really know what's going on there. Okay, well, it might be worth having a look, but you've got to be cynical and be critical about that prediction that you're making because you don't have data to support it. Okay. So what have we got here? Should be pretty obvious. We've got strong positive correlation. This one here, weak positive correlation. Maybe you could argue between strong and weak on that one. This one, outliers. There appear to be one outlier, 2 outliers, no outliers. Well, there's one. There's one outlier, and that's this one here. We don't know why it's an outlier. It might be a bad measuring. It might be some genuine reason why that's an outlier, or it might be that there's some weird thing that happened with that person. So we might make a decision to remove it from the data set, or we might make a decision to keep it depending on the reason why it is an outlier. Okay, what do we got here? I'd say strong negative. Okay, right, stop your video and have a go at this question here. Okay, we've got strong positive correlation. Oops, why am I not able to reveal the graph? I don't know, but the graph would look like this. So we had to plot this information on the graph. So we had 275 roller coaster tickets, 60 ice creams, 275, 60, somewhere like that. Okay, draw a line of best fit. That should have looked something like that. Use your line of best fit to estimate how many ice creams sold with 200. So I think about 40. Let's see, 42 they've said. There'd be some reasonable range for you to get the right answer there. Do you think going on a roller coaster causes people to want ice creams? No, that would be stupid. What it might be the case of is that the more people there are at the roller coaster, the more people there are buying ice creams, just because you tend to be able to buy ice creams at a place where you can go on a roller coaster. Okay, must understand that correlation does not imply causations. Going on a roller coaster doesn't make you want to eat ice cream. It's more that if you're in a place where you can go on a roller coaster, you'll probably buy an ice cream because they sell both in the same place. Okay? You know, they say the third variable here, hot weather probably causes more people to visit the beach resulting in more roller coaster tickets and ice creams sold. Okay. One more. Have a go at this one. Stop your video. Okay, we've got a weak negative correlation here, so you might decide to do some work with this one. It says one student who missed the test took it the next day. The student scored 57 marks and had spent 20 hours watching TV in the previous week. Plot this information in the scatter graph. So 20 hours of watching television, scored 57, so that's maybe somewhere like that. Okay. Another student missed the test and took it later. Could you use the student score and a line of best fit to make confident estimate of the amount of time they spend watching TV? Well, no, you can't really, because if you make a line of best fit, you have no confidence in it. The points are showing a weak correlation, so you know there's a lot of error implied. So it means whatever predictions you make are going to be inherently unreliable. Okay, so no, because the correlation is weak. Okay, we'll stop the video there. The last video is going to be me showing you how to use a calculator to find R, the correlation coefficient, and the line of best fit model. Oh, actually, do you know what? One more question before we go. What about this one? Just look at this one. Several volunteers took part in an experiment. The volunteers took a vocabulary test and then attempted to complete a crossword. Information from the experiment is shown on the scatter diagram. Do you think it makes sense to draw a straight line of best fit for this data? No, definitely not, because it's not a linear relationship. The relationship is curved. What we would need to do is find an appropriate curve. Many of the participants were never able to complete the crossword, so are not shown on the scatter diagram. Estimate the highest vocabulary score amongst these participants. Estimate the highest vocabulary score amongst these participants. Well, I don't really know what it means there. It seems that the highest vocabulary score amongst these participants is about 40, I suppose. I think that's a badly worded question. I think they mean the lowest vocabulary score. It's never really going to get below 10, is it? You can see it's doing that. Okay, that's a poorly worded question. What I want to show you this one for is because you need to look at the data first. Sometimes a linear regression model is not the best model. Okay? Right, watch the video using